In this video, we're going to talk about operations with decimals, specifically adding and subtracting decimals. And we are going to use base 10 blocks to do that. So let's start off with the problem. 1 and 57 hundredths plus 75 hundredths. So remember we talked about last week in our videos how to represent decimals with base 10 blocks. And there are actually multiple different ways to represent decimals with base 10 blocks, and the big thing is to remember to define your whole. So in this case, I could let the flat be my whole, or I could let the cube be my whole. Either way, you would be able to work it out either way. So let's let the flat be the whole here. So if the flat's the whole, and you have to make sure you define this, 1 and 57 hundredths would be one whole. The longs would be your tenths, so 5 longs. And then 7 of the units would be the hundredths place. 1, 2, 3, 4, 5, 6, 7. And if I wanted to add to that 75 hundredths, I would have 0 wholes, which would be the flat in this case. I would have 7 longs, and then 5 units. So when I go to add them together, 7 units plus 5 units, well, I can regroup some of those, right? I can actually regroup 10 of the units and make a long out of that. So when I do, I'm left with 2 units. Same thing with my longs. I have 7 longs here. If I use 3 of the longs from this one, I can put those together and make a flat. So I have 3 longs left over after that regrouping, and then I end up with 2 flats. So my answer for this is 2 flats, 3 longs, 2 units. Well, remember, flat's a whole, so that would be 2 wholes, 3 tenths, 2 hundredths. So 2 and 32 hundredths. Okay. If I wanted to subtract, same thing, it's just I'm taking away here. So subtracting using base 10 blocks, let's do the example of 2 and 375 thousandths minus 1 and 483 thousandths. So in this case, I have to let the cube be my whole. I can't let the flat be my whole, because if the flat was the whole, the longs would be tenths, the hundredths would be units, and then I wouldn't have anything for my thousandths place. So in this case, I have to let the cube be my whole. Okay, so if I wanted to draw 2 and 375 thousandths, that means I'm going to have 2 cubes. 3 flats, 7 longs, and 5 units. And if I want to take away 1 and 483 thousandths, that would be taking away 1 cube, taking away 4 flats, taking away 8 longs, and taking away 3 units. Okay, so let me take away 3 units. And left over, I have 2 units left over. I have 7 longs here, and I want to take away 8 longs. Well, I don't have enough to take away, so I need to regroup. So I'm going to break apart one of my flats into 10 longs. 8, 9, 10. And then I can subtract 8 from that. 1, 2, 3, 4, 5, 6, 7, 8. And left over, I have 9 longs. Moving over to my flats, I have 2 flats. I want to take away 4. That's not enough. So let me break down a cube. A cube is 10 flats. So now I have 12 flats total here, because this one's gone. And I want to take away 4. 4. So I'm left with 1, 2, 3, 4, 5, 6, 7, 8 flats. And then I have 1 cube. I'm taking away 1 cube. So I have no cubes left. So my answer is 0 cubes. I have 8 flats here, 9 longs, and 2 units. So it's 892 thousandths is my answer. Okay. So now let's talk about how we convert decimals to fractions. So the way we convert decimals to fractions is exactly the way that you read them. Okay, so for example, if I wanted to convert the decimal 3 and 429 thousandths into a fraction, so the way I would read it is 3 and 429 thousandths. Oh. So my fraction would be 3, a whole number of 3, and 429 on top. Thousandths would be on bottom, so I'm dividing by 1,000, and that's my fraction. Okay, so then you check and see if you can reduce that fraction. Can I reduce this fraction? So I'm trying to see the two numbers. Is there a number that would divide both into 1,000 and 429? Well, 1,000 can only be divided by 2, 4, 8, like some multiple of 2, and it can only be divided by that and 5. Okay, so up here 429 doesn't divide by 2 or any other even number because it's not even. It also doesn't divide by 5 because it doesn't end in a 0 to 5, so that actually doesn't reduce anymore. So this can't reduce anymore. Okay, let's do another one of those. If I had the decimal 0.0064, the way I would read that is 64, and this is tenths, hundredths, thousandths, 10 thousandths, so 64 10 thousandths. Okay, so as a fraction, it would be 64 over 10,000. Well, I know that reduces because they're both even numbers, so I know that it at least divides by 2. Okay, so can divide by 2. When I divide by 2, I get 32 over 5,000. Well, it divides by 2 again. So I can divide by 2 again, and I get 16 over 2,500. Well, I know it divides by 2 again. When I divide by 2 again, I get 16 divided by 2 is 8. 2,500 divided by 2 is 1,250. And then those are still both even, so I can divide by 2 again. And then I get 625. I know that doesn't reduce anymore because 4 is an even number. The only things that divides into it is 2 and 4. 625 is not divisible by 2 or 4 because it's not even. Okay, so you could also find the greatest common factor of those two numbers and divide by the greatest common factor, and you wouldn't have to divide so many times. The greatest common factor of those two numbers is 16, and so if you just divided by 16 first, you end up here. Okay, Another thing we're going to talk about in this video is scientific notation. Scientific notation is just an efficient way of writing really big or really small numbers. Okay, so it uses powers of 10. And it's a way for writing small and large numbers. It uses power of 10s to write small and large numbers. Okay, so for something to be in scientific notation, it has to be a number between 1 and 10. And then, so it's some number between some number between 1 and 10, and then it's multiplied by 10 raised to some power. And this power could be a positive power, or it could be a negative power. Okay, so for example, a number between 1 and 10, 5.423 times 10 to the, let's raise it to the 8th power. Okay, so that means this is going to be a really big number, because if I multiply by 10 to the 8th power, that's basically multiplying by a number that has 8 zeros on the end of it. So the process here, this right here means to move your decimal to the right, and you want to move it to the right 8 times. So for this problem, 5.423, if I move my decimal to the right 8 times, 1, 2, 3, 4, 5, 6, 7, 8, there's where my decimal place is going to be, and then I need to fill this number in with zeros. So my answer would be 542,300,000. 1, 2, 3, 4, 5. Yeah. Okay, so that's how to represent a really large number in scientific notation. If I wanted to show a really small number in scientific notation, I would use a negative exponent. So 6.23 times 10 to the negative 4th power. This means move your decimal to the left 4 times. So for this problem, if I was going to move it left, it would be 1, 2, 3, 4 times. So that's where my decimal place is. I got to fill in with zeros. So this would be 0.000623. And the correct way to read that would be 623 tenths, hundreds, thousands, 10,000s, 100,000s, millions. So 623 millionths. Okay, in the next video we'll talk about multiplying and dividing decimals.